When you calculate a slope, there are four different types of numbers you can get. Positive number, a negative number, a number that is an undefined fraction, or zero. Here's what these tell you about the lines. A positive slope will be an increasing line as you read from left to right. A negative slope will decrease. An undefined slope is always represented as a vertical line, and a zero slope would be represented as a horizontal line. Positive slope lines will have both variables, an x and a y, as will negatively sloped lines. But undefined slope lines will have an equation that has only one variable, and it will always be x, whereas the zero slope line will have one variable, but it will always be y. An example of a positively sloped line is 3x minus 1. The 3 in front of the x is the slope. A negatively sloped line example would be this one. Negative 3 in front of the x means the slope is negative. Here's the equation of a vertical line. Vertical lines will always begin with x equals. And here's the equation of a horizontal line. Horizontal lines will always begin y equals. You should remember having learned about the slope-intercept form of a line. The general equation is y equals mx plus b, where m always represents the slope of the line and b is the y-intercept of the line. That means where the line will cross the y-axis. Let's take a look at a sample problem from Mymathlab. You are asked to give the slope and y-intercept of the line whose equation is given as f of x equals negative 3/4 x plus 7, and then you're asked to graph that linear function. First of all, please realize that f of x is just one way to name the output of a function. We could write this equation equivalently as y equals negative 3/4 x. Now remember, the general form of a line is y equals mx plus b, where the coefficient on the x is always the slope. So in our example, the slope would be negative 3/4. The y-intercept for a line is always the b value, and the b value in our case is 7. This gives us the information to answer the first couple of questions. The slope of this line is going to be negative 3/4. And using the palette, you can type a fraction. The y-intercept would be positive 7. Then you would use the graphing tool in Mymathlab to graph this line. A button will appear at the bottom of the question when you're ready to graph. Click that button. The directions at the top of the pop-up window tell you first to plot the first point of your line. That's your y-intercept. Make sure you select this tool, which is the line tool. Once you've clicked and located your y-intercept, the directions at the top now say click the graph to plot the second point on your line. So now use your slope, your rise over run, to move to your next point. The line tool will automatically draw the line as you drag the second point into place. When you're done, hit the save button at the bottom. Now let's go back to doing the problem by hand, and I'll take you through those steps more slowly. The way that you graph the line is by always starting from the y-intercept. The y-intercept tells you where the line crosses the y-axis. In this case, it's at 7. So I find 7 on the y-axis and I put a point there. That's the first point that will belong to this line. The slope tells me the rise over run of the graph. The rise indicates that you would move up or down. If it's a positive number, you're going to move up. If it's a negative number, you're going to move down. The run is telling you whether you're going to move left or right on the graph. And in most cases, this bottom number is almost always going to be positive, which means go to the right. If it was negative, it would mean go to the left. And when you have a negative sign out in front of a fraction, you should consider it to be part of the numerator. Do not put it on both the numerator and the denominator. My rise is a negative 3. That means I'm going to go down 3 units, and then immediately afterwards, I will go 4 units to the right. I do this starting at my y-intercept. I go down 3, right 4. And I put another point down. I continue this pattern. Down 3, right 4. I can also get more points on the line by doing the exact opposite. From the y-intercept, I can go up 3 and left 4. Once you have enough points, you would just connect them with a line. And we would put arrows on the ends of the line to indicate it keeps going and going in each direction. Now, we can verify that this actually works by doing one extra step. We can take the coordinates of any point on the line, such as the point 4, 4, and we can substitute that into our original equation, putting the y in place of the f of x. I substitute for x and y, which in this case they're both 4, and then I perform the calculations on the right-hand side. And what you'll notice is that this statement is true. In other words, this point checked in the equation of the line, so it definitely belongs there. This will be true for any of these points that you substitute. Let's take a look at another example. This time we're asked to graph the equation f of x equals 8. Now again, I'm going to suggest that you change it to y equals 8. And there's only one variable here. And there's two ways to think about this. To graph y equals 8, you could make a table of values like you saw in our previous video, where I picked x values and then calculated y values. But here's the thing. I can pick any x values I want because x doesn't even appear in the equation. What it tells me is this is a constant function. The output is always 8. And you can draw this line then by plotting those points. And that gives you this horizontal line. The other way to do this is just, when you do enough of them, you basically end up memorizing it. Anytime you have a line that has one variable and begins with a y, that line will always be horizontal and located at 8 on the y-axis. Compare that to this example. I'm given the equation 5x minus 20. Now hopefully you remember a little bit of basic equation solving. This only has one variable, and I want to get that one variable by itself. To begin solving this equation, I'm going to do the opposite operation here. This is subtract 20. The opposite of that would be to add 20. What you do on one side of the equal sign, you have to do to the other. That gives me a 5x. These cancel, which is helpful because I'm trying to get x alone. And 0 plus 20 is 20. Now I still have a 5 sitting next to my x. This is 5 times x. So the opposite operation would be to divide by 5. What I do on one side, I do on the other. 5 divided by 5 reduces to 1, leaving me just with 1x equals 4. And just like in the last example, there's two ways you can think about graphing this line. You can make a table of values. In this case, I'm told x should always be 4, so I would automatically have to fill 4s in here, and I'm not told anything about y, so y is the variable that can change. I go to the graph, and I find these points and plot them. Notice I've created a vertical line. Once you do enough of these and sense the pattern, anytime you have an equation that has only one variable and that variable is an x, it will be a vertical line and it will be located at 4 on the x-axis.